Thank you very much, Mr. Chairman. Welcome to Maastricht, the place where I work and live. And I am faced with two big challenges. First of all, who of you had already lunch? Huh? See, there's the problem, and we are talking about feeding. The second problem is, this morning, Nena Modi proclaimed, we don't know anything about feeding. Well, who am I to object? So, ladies and gentlemen, are we causing harm in fortification? I want to summarize my talk with this slide. Please excuse the poor quality. It has come all the way from Australia and is already very old. This woman is 35 and she's pregnant, and she is very much concerned about the sound and the noise of the jackhammers from this construction site. So, do you think she gets her priorities right? No. We are much more concerned about her smoking. So I want you to revisit what you are doing on the unit and to set the right priorities. What are the right priorities? This will be open to discussion. So let's have a look how we look into this. I give you a case, and we call this little girl Bella, the beautiful, 26 plus 1 weeks. She's stable on CPAP, 6 centimeters of water, 23% oxygen, and she is intrauterine growth restricted. She is under the 3rd percentile. So, how do you feed this baby in the first 24 hours? Who would, please raise your hand, who would give breast milk, mother's own breast milk, in the first 24 hours? Okay, great. Who would give formula in the first 24 hours? Okay. And if mother's own breast milk is not available, who has the opportunity to use donor milk? Okay. Who would like to have donor milk but does not have it? Oh, geez. I think we have seen a new business opportunity here. Okay, so how would you advance the enteral feeds? Would you advance this on a daily basis or look in an individualized manner? Who goes for an individualized manner? Okay, good. So, in the first day, we have to give some parenteral nutrition. How many amino acids would you give on the first day? Who would give 2? Who would give 3? Who would give 4? Any other suggestions? None. None. Oh, wow. Okay. Why that? Not available. Okay, that's an issue. Another business opportunity. So, how many lipids would you give? None? Who gives none? 1 gram per kilogram? 2? 3? Okay, may the evidence be with us. So, the American Academy of Pediatrics recommends that preterm infants should achieve rates of growth and composition of weight gain for a normal fetus of the same postmenstrual age and to maintain normal concentrations of blood and tissue nutrients. Isn't that nice? What is the background behind that? A one-liner. All outcomes are poor if the baby does not grow well. You have to get back into this growth chart of the in utero development, which is derailed by the preterm birth. And if there are no calories, the baby will not grow. And why are the calories so important? We know these beautiful MRI scans and models how complex the brain will be over the gestational age. But if you look at it from a caloric standpoint, you get an idea of how much energy is being used for this perinatal brain growth. So if this does not grow, we have a long-lasting problem. And just to give you an idea, we are looking at 250,000 neurons per minute. Just think how many neurons you have lost because of the alcohol yesterday evening. So this is old news. If you don't have calories, if you don't have protein as the gold currency standard of metabolism, your outcomes will be poor. This is 10-year-old data. If you don't have the opportunity to grow, you will not do well. And the growth and neurodevelopmental outcomes are not only linked in the short-term period of time, but also in the long-term period of time. Or to put it this way, the intrauterine growth is a unique opportunity to set the basis on which a happy, successful, healthy development is being based. All the aspects of human development. And we have to achieve this outside the natural environment. And if we think about this, how are we mimicking the intrauterine environment? From a metabolic standpoint, the mom takes over the heat production so that the baby can use its energy to grow and differentiate. We are doing this with our incubators. The baby is parenterally fed by the mother. Do you know how many amino acids a baby gets per day by umbilical cord? 1, 2, 3, 4? 4. Here we go. So why are we so restricted to give amino acids after birth? Just look at that, how growth is related at longer time outcomes. And not only in body weight, but also in length and development. So we have to get these babies to grow. So in utero, how many lipids does it get? Well, you have seen the slide already, I'm sorry. So we get, the fetus gets 4 grams of amino acids and 3 gram lipids, till the very moment that we or the obstetrician cut the umbilical cord. And then we get concerned and start based on availability, amino acids at 2 or 3 grams, some give 4 grams, lipids with 1 gram or 2 grams, some with 3 grams. So it is inherent that the baby will be short of calories. Why are we so reluctant? Well, in the old times when I was young, the preparations were not of that quality that they could be that easily tolerated. But if we do not pay attention what the fetal energy and caloric intake is, we will go invariably into a caloric deficiency. And to give you an idea, we have looked now at the brain as an outcome, but there's also a lung. This is something that the brain people usually ignore, but I'm originally a lung guy. You have the whole range between a normal lung development and a highly simplified lung structure, and you have everything in between in preterm babies. That is the reason why in this huge spectrum a single point of diagnosis of BPD is so ridiculous, because it does not reflect the broad spectrum of developmental outcomes. However, it is known that without nutrition and appropriate vitamins, this is getting nowhere. And just to show you how important this is, I have here an experimental model where you do caloric restriction for 15 days, and you see how the lung development is simplified. So just without any additional injury, without inflammation, oxygen toxicity, mechanical ventilation, just by reducing the caloric intake, you are simplifying the lung development, and you have a problem. Well, the interesting thing is you can have some plasticity, and it gets back on track with the reintroduction of feeding. So, key points. You can do a lot of things with good feeding with respect to outcomes. Why are we not focusing on that? Why? Well, those studies are extremely difficult to conduct. And this starts with the way how we look into that. Is it appropriate? Is it appropriate? Here you have the intrauterine growth charts between the 10th and the 50th percentile, 24-weeker, 26-weeker, 28-weeker. This green line is what we want to see. A small, short dip, and then appropriate growth into the chart where the baby is originally coming from. Is it here that a less skilled team is doing its job, or that the availability of preparations is not there? And if you see this chart, well, you already know that trouble is around. If a baby does not grow, all outcomes will be bad. So, what tools do we have at hand? Mother's own milk. We have made this call. That's the way to go. Donor milk. Well, donor milk, where does it come from? It comes from women who have been lactating for a long period of time. And if we remember, the composition of the breast milk depends on the gestational age when the mother gives birth and on the duration of lactation. So the energy content of donor milk is inherently low. And we have introduced now donor milk 2 years ago, and we are still struggling to find an optimal point. Sorry. To find the optimal point with this low caloric donor milk to do the right thing. Fortifiers. Who uses fortifiers? Who does not use fortifiers in his unit? Why not? Sorry? You don't have them. If they were available, would you use them? Yes. Okay. Who is using a bovine product? Who is using a human product? Who would like to use a human product? So we are concerned of introducing a different species proteins. And why? Well, first of all, we have to check reality. This is how we write our feeding protocol for the unit. This is how we prescribe the nutrition. And the green line is the reality. I do not reveal from which unit this is, but do you have any doubts that you have a chart like this in your unit? So now we have theoretical ideas how we want to feed it. We have knowledge that the composition of the milk is changing, but how do we get a grip on that? I ask you, who is measuring the caloric content of the milk that the mothers express and put in the refrigerator? And do you find a huge variation to the published numbers in composition? Yes, you do. You see, this chart is overtly simple. It does not even have standard errors of the mean or standard deviations. Isn't this great, this idea that it is like this? Those who have the opportunity to measure will find a huge variation, and they can then approach this problem. However, the poor people like myself has programs where I type in the gestational age and the numbers will be used, and I'm given a number that the baby receives more than 4 grams of proteins, and the baby still does not grow. Why? It is assumed that I know the protein content and the energy content of the milk. And that is unacceptable that the babies don't adhere to the protocols that we write. So, all preterm infants should receive human milk. Human milk should be fortified, and mother's own milk is preferred. Who is pasteurizing mother's own milk? Why are you doing this? CMV. That's a very interesting question. We will save this for the coffee afterwards. Because it is interesting, the fear of CMV, where we have not really strong data, is then resulting in killing the microbiome of the breast milk. And I will show you data from a meta-analysis that we did on the effects of breast milk on BPD. And we found that only raw mother's own breast milk and not pasteurized mother's own breast milk is beneficial in protecting against BPD. So now I come to a very serious subject. Are there nurses here? Yes. Are you told to check the gastric residues in your unit? Yeah. This is an issue. I have not found a way to tackle this in my unit. We know that there is no benefit with respect to neck. And this beautiful study, which was published earlier this year, shows if you go for gastric residue evaluation, you are delaying the enteral intake. You are too much confused by something you measure that has no relevance. And when I discussed this with my nurses, they said, but we have been doing this for all our lifetime. So what I realized, I did the wrong way. I told them that it was wrong what they have been doing for all their lifetime. So that is not the right way. And I'm open to suggestions how to tackle this. Now we have even prospectively studied what we all knew that was sitting around, that checking the gastric residues has no benefit. So now coming back to Bella. She is 660 grams. She's on mother's own milk. And if we go now for a bovine supplementation, we would get, assuming that we have 0.9 grams per deciliter protein in the milk, a 2.3 gram of protein preparation. But what is really amazing is the distribution of the source of protein. The human protein is in minority. And it has been long known that depending on the source of the fortifier, your gut microbiome changes. Other bacteria profit from the bovine proteins that are then available. And we know from many studies that the microbiome plays a role, in addition to all the benefits of breast milk. And if we look very carefully at the nutritional studies, we have to see that we are looking at actually 4 types of studies. Preterm formula, mother's own milk with a bovine fortification, something in between mother's own milk, bovine fortification, and preterm formula, and an exclusively human milk diet where you have human milk fortification. And this is an example. How many incidences of feeding intolerance did those 4 groups have? And in yellow you have no incidence of feeding intolerance, in blue 1, in red more than 2 or more incidences. And you see those who have been given exclusively human breast milk, they have the least incidences. Well, this is concerning. And if you now look what we know from the development of the microbiome and the association of gut, we cannot pinpoint to one type of microbiome, but we know that the diversity is changing, and this is true throughout the world. This is data from colleagues in Brazil who have shown this in the changes. So we got interested in the composition of the gut microbiome. And to do this in a genetic analysis, it takes a lot of time. We were more interested in the metabolic activity of those bacteria. So we used a nice device called electronic nose. And the electronic nose is mimicking the situation in the human nose. So you have sensors that can detect certain patterns of organic molecules called volatile organic compounds. And these volatile organic compounds are the metabolites of the microbiome. And depending on the number of receptors, you have several sources of information. And the receptor is either activated or not activated. And then you have a reference pattern to put this into context. So if we smell food, and it smells nice, well, then we will like that, but we can also check for contamination of food. So the reference memory is key to actually see what is happening. Well, if we have a baby that has a clinical deterioration and the tummy is distended, we cannot differentiate it between sepsis and NEC. So we asked the question in this clinical trial, if we collect every day the feces and then analyze the spectrum of metabolic activities, do we find a pattern that is changing over time and can differentiate between NEC and controls and NEC and sepsis? And here we use 17 different receptors. So you have mathematically a 17-dimensional information. I have asked the mathematicians to reduce it to 2 dimensions. And then you see those kind of patterns. So these were the babies that developed NEC, and they can be differentiated from the babies who did not develop NEC. And even more nicely, you can differentiate NEC from sepsis. So this is very interesting, both from a biological standpoint and also from a therapeutic standpoint. And we looked, when do we get this information? Time point 0 was the onset of clinical symptoms, and we looked at 3 intervals. 24 hours before the onset of symptoms, 48 to 72 hours before the onset of symptoms, 96 to 120 hours. So 2 to 3 days before, 4 to 5 days. And you can see within 48 to 70 hours ahead of time, you can differentiate this with a sensitivity of 83% and a specificity of 75%. not that bad for the kind of tests. So imagine the nurse changes the diaper, gets a scoop of the stool, puts it into your electronic nose, and the electronic nose says, this baby has a 95% risk to develop within the next 48 hours. What would we do? What would we do with this information? This is where we are now chewing. Would we start antibiotics? Systemically? Locally? Would we stop feeding mother's own raw breast milk to stop? Would we give probiotics to change the disbalance in the microbiome when we have 48 hours until the onset of clinical symptoms? So this is where we are with this problem. Just to give you an idea what the basic reflex of antibiotics will do. Here you have 3 examples of no antibiotics and the development of the gut microbiome over 6 weeks. You see, this is then the reference pattern. If we decide to give for 2 days antibiotics, you see it takes 6 weeks to recover from the changes induced by antibiotics. And if we decide to give 7 days of antibiotics, 6 weeks are not enough for the changes to recover. So that's the reason why we have introduced the rule in the unit. If you start antibiotics, your prescription is limited for 48 hours. After 48 hours, you have to revisit your decision or your colleague's decision, look at all the results from microbiology, look at the baby, and then decide whether you want to go on or keep it like that. So why is this so important? I told you this is a meta-analysis we did on clinical studies looking at the effects of mother's own milk on BPD. And the question whether you use raw mother's own milk versus pasteurized mother's own milk is of interest. So look at that. If you give raw mother's own milk, you reduce the incidence of BPD. If you do not pasteurize it, you lose this benefit. So the microbiome has a role in that. And now you will ask myself, why does a raw breast milk that will definitely affect the gut microbiome will have a role in the development of BPD? That's a difficult one. We did a retrospective analysis in our neck-nose data and found that the composition of the gut microbiome changes in babies that will develop severe BPD weeks ahead of the diagnosis of BPD. And if you look carefully in the literature, there is a so-called gut-lung axis described. However, how the circulation of bacteria from the gut into other epithelial surfaces is happening, we have no idea. And Christian Poetz has already taken this into a clinical trial, and he asked the question, can I change the gut microbiome in the mother in order to reduce the incidence of adverse outcomes like stillbirth or preterm birth? So he supplemented the diet of pregnant women. However, that did not affect the primary outcome. So there is a biological idea to that, and there is the future of applications for that. However, we need to get started and do this. So may I show you the growth chart of Bella? What do you think of this growth chart? Be honest, come on. I can take it. So we introduce a bovine milk fortifier only if we have achieved full enteral feeds. We want to delay the introduction of cow's protein for that period of time. This was the first time when she was on full enteral feeds. We introduced in a low concentration the bovine fortification. The belly almost exploded. We stopped immediately enteral feeds. We started antibiotics. We recovered. The baby recovered. We restarted enteral feeds, and we had the same experience here. And then we said, oh, is it possible that we have babies that do not tolerate this bovine origin? Well, and then we had the opportunity to introduce a human breast milk fortification. And this is what's happening. No incidence of sepsis along that way, and the baby is putting on weight, and it is in a good clinical condition, and now we are revisiting our data. Is it worth to have this kind of situation and delay for 2 weeks, or even more than 2 weeks, the weight gain in babies, that we are not able to provide sufficient protein and calories for the growth in this sensitive period of time? I am honest with you, I have n=1 of that babies. The next one is soliciting for that. That's a 24-weeker who's not tolerating the bovine fortifier as well. But this was a scenario that we considered based on the individual situation. So I have been talking to you about the implications of growth and the microbiome. Is there anything I can really present you that it makes a difference? Well, I can present you an association that we found. This is data that will be further presented by Christian van Gansewinkel in this conference. And he looked at the long-term follow-up of the so-called PUPS study. These are preterm babies at the age of 19 years, and they have undergone a cold pressor test. You put your hand into ice-cold water, and you have to report how much pain you perceive, and the time is measured how long you can withstand this. And after controlling for gender, disease severity, only one disease stuck out: necrotizing enterocolitis. If you are a survivor of necrotizing enterocolitis, you have a reduced pain tolerance and a higher and a lower pain threshold at adulthood than anyone else. So we have summarized this experience that we have a gut microbiome that provides 90% of the input into the nervus vagus, that we have a highly metabolic active gut microbiome that is driving, for example, the propulsions of the gut. The colleagues from Lundberg have beautifully published that the babies who will develop NEC will have a lower number of spontaneous stool passages than those babies who do not have develop NEC. So this composition of the gut microbiome has such a metabolic activity that it even drives propulsion of the gut. And you will look very differently at CPAP valleys these days if I tell you that high oxygen contents in the gut lumen will kill the anaerobic bacteria, and this changes then both the metabolic situation and also the local inflammatory situation, and makes ischemia more likely than in situations where you have a symbiotic gut microbiome and a happily and healthily metabolic activity. So the take to work messages: the microbiome is relevant. It has multiple functions. We are starting to appreciate that. We affect the microbiome in many ways, and feeding is one of them. And if we introduce non-human species, it is a very difficult one. To get a grip on that, both in clinical terms and in scientific terms, is very difficult. We are experimenting with the eNOS as a compromise to really get a hold on these metabolic activities which appear to be important. So this is the way how we have experienced this in order to give a better helping hand to our preterm babies. And I thank you for the attention, and I'm happy to take questions.